Welcome to Cooking with Starlight, light from our nearest star. If you are messing about with solar cookers, always wear sunglasses, please. Today I'm going to be looking at the elements that make up a solar cooker. We're going to put together a very simple solar cooker so you can see how they work. Let's get going. Okay, let's make a very simple solar cooker so we can look at the elements that make up a solar cooker. This is a black target. This is one of the components of a solar cooker. Sunlight hits the black target, gets absorbed and heats up the target. And if we just leave this there in the sunlight, it's nice and warm to the touch, but it's not really hot enough to cook any food, but it's a start. We can introduce the second element now, which is reflectors. If I reflect some more sunlight onto this target, it's going to heat up even quicker. I hope you can see from up there that we've now got 3 mirrors reflecting sunlight onto this pot, which means it is going to heat up even more quickly. But there's a problem. Just as this is heating up, it's getting hotter than its surroundings, so it's losing heat to its surroundings. So we need to introduce the third element of a solar cooker, which is finding ways of insulating this so that it doesn't lose as much heat. The first thing we can do is to put a lid on the pot. That will stop warm air from rising out of the pot and blowing away in the breeze. The next thing we could do is use a glass heat trap. Now we've put this in a heat trap and the sun can still get to the target, but less of the air that the pot heats up round it can escape. And of course, if we put a lid on, that completes our heat trap. But there's heat escaping somewhere else as well. As the pot heats up, the bottom of it is in contact with the glass heat trap, and it's just going to conduct heat away through the bottom. So what can we do about that? We can use a trivet to hold the target away from the glass bottom of the heat trap. So now this trivet will hold the bottom of the target away from the bottom of the heat trap and complete the picture. And there we have it. A very simple solar cooker that has 3 elements. The black target, which absorbs the sunlight and turns it to heat. The reflectors, which reflect more sunlight onto the target to heat it quicker. And various ways of insulating the target once it begins to get hotter. Let's go and look at some proper solar cookers over here and look for those 3 elements. Here we have a panel cooker. It's called a panel cooker because it's made out of panels. This could be thought of as the slow cooker of the solar cooker world. Let's look for our 3 components. Inside we can see a dark coloured pot, a largish reflector which has a nice curve on the back which concentrates much more light onto the target. And then the insulation is just the same as we saw before. We've got a glass heat trap with a lid. There's a lid on the pot inside and it's raised up on a trivet. And all of those contribute to keeping more heat inside the cooking vessel. Let's go on to our next cooker. Next up, we've got a box cooker. It's called a box cooker because it's a box with a glass lid. Let's look inside and find the dark coloured target. As you can see, the whole of the inside is black, and that's the target. You can see something cooking there. That's going to be ready in another hour or so. And we can see the reflector here, which reflects more sunlight into the box. And of course, we've got to look for insulation, and you'll notice that this is a double glazed piece of glass on the top, which prevents too much heat escaping. And the whole of this box, you can see how thick the sides are. It's very well insulated. So again, we've got our three components. We've got a dark coloured target, a reflector, and ways of insulating to prevent the heat from escaping. This is called a tube cooker because you cook inside a tube. Let's look for the target, dark surface. You can see the target inside the tube. That's where the sunlight gets absorbed and turned into heat. The reflector is obvious. All of the sunlight that hits this reflector ends up on the tube. And so we've got a large area of sunlight hitting this tube. Insulation. This is a double-skinned glass tube, and in between the two glass skins there is a vacuum, just like in a thermos flask where you might keep coffee. And that provides very, very effective insulation. In fact, I can easily put my hand on the glass here. It's warm but not very hot, whereas inside you can see that the air inside this tube is at 200 degrees centigrade, and you can see steam coming out. Always use oven gloves or you'll burn yourself. We'll leave that there to cool and go on to our next cooker. Our next cooker is called a parabolic cooker because of this curve here in the reflector. That's a parabola, and that reflects all of the sunlight up to this hob here. Here's the black target, in this case a kettle, and I'll just turn it into the sun so that you can hear it boil. So where is the insulation? The answer is that there isn't any. This very large mirror produces so much power that we don't really need to insulate this. It just provides the same sort of power as you might get on a small electric hob in your own kitchen. It's certainly enough to boil a litre of water in about 12 minutes, which isn't too bad. That's all for today. If you are messing around with solar cookers, please always wear sunglasses.